So as you can see, today is Monday the 30th of April, and this is what we went through today in class. Now you've done this before with the arithmetic ones, and now we are going to do it for the geometric ones. And we had a situation where we have non-consecutive terms given, and we need to find R, we need to find A, our beginning. So we don't have A, there it says, so term 1, which is the same as A, we don't have that. We have been given term 2, which happens to be 20 here. Now the second term there, term 2, which we put here. The term 3 we have not been given, and term 3 is equivalent to A times R squared. We don't have the fourth, the fifth, but we do have the sixth term, which is 320. So put that here. Okay. Now remember, these ones are step sizes, and you need to imagine that you actually grow at the same time as you are taking the next step. So each step is going to be bigger than the previous one. Now that's a little bit hard to imagine, but that's just how it is. So let's just go from this one then. So in order to get from here to here, we need to multiply by 1r, that's just 1r, and because we want to go further than that, we need to multiply by a second r, which is 2r's, and to get from there to there, from the second to the fifth, we need to multiply by 3r's, and last but not least, to get from term 2 to term 6, we need to apply by 4r's. Okay, so whatever r is, 20 times r gives us term 3, times r gives us term 4, times r gives us term 5, times r gives us term 6. Now, if we write that down in algebraic notation, we are literally saying that the second term multiplied, let's get rid of that, the second term multiplied by 4r's, or r to the 4. Remember, r times r times r times r equals r to the power of 4. It is not 4r, it's r to the power of 4. So we are saying that if we take the second term and we multiply by 4r's, we end up with the sixth term. Okay, so once we got this one, it is easy to simply substitute. Okay, so we know that term 2 is 20 times r to the power of 4 equals 320. So that's all we did. We substituted our second term there, and we substituted our sixth term there. And from there, we only have one unknown, one variable that we need to solve for. So now we're doing algebra again. We want that r by itself. So we go get rid of that one. And the operation that we are doing here is multiplication. So we do the opposite. In our case is division. So we divide by 20, which gives us then r to the power of 4 is the same as 320 over 20. Now we need to know 1r and not 4r. So how do we get rid of those 4r's? So the easiest way is just take the fourth root. Okay, so you all know how to get the square root. So r times r is the same as r squared. And a squared literally means what two numbers multiplied together, or well, the same numbers, or which number multiplied by itself equals such and such, right? So what we do is we just take the square root. But this time we don't have an r square, we have an r to the power of 4. We need to take the fourth root, not the second root. So what we're going to do is we take in the fourth root of r to the power of 4 equals the same as the fourth root of 320 over 20. Okay, so this all cancels out, so that square root cancels with that one, so we end up with r only, and then we get a number here, and I need to get that number up from, that's going to take a while, so sorry for that. Class pad. There we go. So let's see how we go here. We're getting anywhere? There we are. In your own time. So now I want to continue with my current license. And we are back in business. Come on. Alright, so we're doing that in main. I'm just going to bring that over here so you can see what I'm doing. So I bring up our keyboard and I want to have this symbol there, which lets me pick which root. Okay, so I take the fourth root of, and then I use a fraction there, 320 over 20, and that gives us 2. Fantastic. So now that we know that R is 2, we need to find I, and nothing could be easier than that. Let's move that up here, and again we use the same approach. Okay, the same approach, nothing has changed. So literally now we go back to our generic equation, which is Tn equals A times R to the n minus 1. Now it's before with the arithmetic one, so we can either use T2, which is 20, or we can use T6, which is 320. Okay, so let's just substitute 1 with the, it does work either way, it doesn't matter which way it is. So we replace this Tn with T2 with the very specific one. R is the unknown. We multiply by 2, which we've just found, that's our R, and we do 2 to the power of 2 minus 1, because remember that's n. That n is the same, so if we put it n, if we make n equal 2, then we need to make n equal 2 up here as well. Now we can simplify, and now we can simplify. A times 2 to the power of 1. Okay, so in our case, well, that becomes 2, but let's just not go there. So, and now we substitute that 20 into here, so meaning that 20 equals A times 2 to the power of 1. And let me just show you what happens if you take 2 to the power of 1. Well, you get just 2. Okay, so, and then we can do that here. We do algebra, so we go divided by 2, which gives us A equals 20 over 2, and A equals 10. And that's really it. And now we want to find the common sequence rule. So now we have everything together. So we have everything. We got A, tick, we got R, tick, and that n minus 1 stays the same. So we start with 10 multiplied by 2, that's our R to the n minus 1, and that is the answer for B. And in order to find the 10th term, we just say, okay, so T10 is the same as 10 times 2 to the power of 10 minus 1. And we can do that using our calculator. Let's bring that over here so you can see. It's 10 times 2, 10 times 2, and then we go to the power of 10 minus 1, which is 5,120. And that is our final answer.